Hello there, Band 3. Welcome to Learn with Ceri. In this video, I've got some tips and tricks for Quest 2. Let's start with question 3. The expression 21 times 15 plus 39 times 7 can be written as 7 times 7 times something else. What whole number goes into the box? You might want to press pause and give this another go. What's really helpful to notice is that the 21 is 7 times 3. So that's where we're going to get another 7 from. And so I've rewritten this as 7 times 3 times 15 plus the 39 times the 7. So then we've got lots of 7s. So we've actually got 3 times 15, 45 lots of 7s in the first part of the expression and 39 lots of 7s in the second expression. So altogether we've got 45 plus 39 lots of 7s. So we know when we add 39 we can just add 40 and take away 1. So that would give us 84. So this expression is actually 84 lots of 7. Now, is 84 a multiple of 7? Yes, it is. 70 plus 14. So it's 12 lots of 7. So this is actually 12 lots of 7 and then times by that extra 7. And there we go, we've solved it. 12 must be the number in the box. Next, I'd like to take a look at question 4 with you. In the diagram below, ABCD and BCFE are parallelograms. Angle DAB is 131. I'm just going to stop there and just add that on. So D to A to B is this angle here, so 131. And we know that opposite angles in a parallelogram are equal, so that's also 131. Fab. And then let's keep going. BEF is 112. Okay, B to E to F. So we've got B to E to F. That's this angle here. So just in case you weren't sure about how to use the notation, then you look at B, E, F in order. It's the angle, it always ends up around the middle letter E, but from B to E to F creates this turn here. Okay, so we know that that's 112, and the opposite angle up here will also be 112. So then we've got a full turn there. Let's just put a highlighter on it for a second. Let's show that there is 360. So now we can solve our problem. We've got 360, take off 131 and then take off 112. Personally, I'd prefer to take it off in one go, and it's a nice number, so that's going to give us 243 to take away. And then personally I would then count up, so I would count up that I need an extra 17 to make 260 and then an extra 100, so I would actually get the final answer 117 degrees. I'm just going to do that there because that's not quite part of the same. There we go. Okay, hope that helped you with a few quick ways there as well. Well, I haven't done a fractions questions yet with you, so let's have a look at a fractions question. Question 5, 2 pairs of equivalent fractions are written below. What's the value of x? Okay, so they're equivalent, so whatever this one gets multiplied by, which is 6, then the denominator is also multiplied by 6, because then they're in proportion, they're the same equivalent fraction. Well, it's the same numbers again over here. A and B are the same numbers, so it must still be a relationship, which is times 6. So what we need to do is 13 times 6. And 13 times 6, I do 10 times 6 and then 3 times 6 and then add my answers, because then I can quickly do 60 add 18 in my head. And 78 is the number we're looking for. There you go. Oh, question 10 has a lot of words. Consider the pattern of the shapes below, but I put it above, I hope you don't mind. To go from one shape to the next, we attach a regular polygon with one more side to the far left and far right of the figure. I hope you don't mind, but I'm just going to jump to the end, we have to work out the perimeter of the shape that we get if that keeps growing and after we attach two 100-agons. Right, okay. Well, the 100-agon is going to be added. Which pattern number would we be on? This is pattern number 1. Pattern number 2 was squares, 4-sided shape. Pattern number 3 was pentagons, 5-sided shape. So we need to know pattern number 98's perimeter. That's our big question mark. What would the size of the perimeter be by number 98? Because that's when you'd add two 100-agons on the end. Okay, let's have a little look at this. I'm going to use my highlighter a bit. We've got 3 sides. Okay, no problem. But we lose 2 of those sides when they get connected to squares. So then we've only got 1 of those then. I'm just going to change the colour and go for the perimeter of the squares that we add. We've got, because those 2 connected, there's 6 edges from the 2 squares that are part of the perimeter. And then if I just repeat that colour coding there, and then if I add my pentagons on one of the sides of the squares, I just want to get my head around what's going on here. Okay, one of my sides of my squares is no longer part of the perimeter. Let's have a look at our numbers next. Let's write down our pattern. We've got pattern number 1 has got a perimeter of 3. Pattern number 2 has got a perimeter of 3 plus 3 plus 1 is 7. Pattern number 3 has got a perimeter of 1 orange, 4 greens, and then 8 blues. So that gives us 13 as the perimeter. On the 4th one, let's just think what happens with the 4th one. We're going to have 1 from the triangle, 4 from the squares. Currently we've got 8 in the 3rd pattern from the pentagons, but that's going to reduce to 6 because they're going to touch the new hexagons, and the new hexagons 6 sides, but one of them touches, so we've got 5 and 5 makes 10, so we've got 21 there. Okay, perimeter of 21, and I'll just do one more just for fun. I've got the 1 plus the 4 plus the 6. Now the hexagons are going to be touching, so that's going to go down to 8, and the heptagons, we're going to have 6 from each, so that makes an extra 12, so that gives me 20, 30, 31. Okay, I think I've got enough numbers now to find a really good pattern. There is a way to do it by considering how it's going up, but we have got to get all the way to 98, so I don't fancy it. No, well, it wouldn't be time, would there? So let's have a look what's going on with these numbers, because there is something I can show you that will be useful even up to 6th form challenges. So it's gone, this one has increased from the 1st to the 2nd. It increases perimeter by 4, perimeter then increases by 6, perimeter then increases by 8, perimeter then increases by 10. All right, can you see what's going on here? This is called the second difference. So the differences are also going up an extra 2 every single time. And when there's a pattern like that in the second differences, then it's linked somehow to the square numbers, right? So 1 squared is 1. I'm just going to make a little note here that that's what I'm looking at. If my pattern number is n, then n squared would be 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. We are going to need 98 squared. Let's have a look. Can we see any kind of connection then between the square numbers and the numbers in our growing pattern? So that's 2 extra. That's 4 plus 3 is 7. That's 9 plus 4 is 13. 16 plus 5 is 21. And 25 plus 6 is 31. So whatever we get, the adding, this little blue adding that we're doing, is 1 more than the pattern number. So this is going to be a plus 99. But we need to know what 98 squared is. My preferred method is to do a lattice method, or maybe you've got good ways of doing square numbers. There are some clever tricks. Okay, so I'm just going to fill this in 81, 72 and solve this. So that's units 4, 262 is 10, that makes 16. So 9,604 is 98 squared. So when we add our 99, we get the final answer of 9,703. That would be the perimeter of the 98th shape picture, and the 98th picture is the one where 2 100-agons got added on. Tricky, but actually not bad if you, and wouldn't take long if you knew about the connection to the square numbers. So hopefully that's something you can use again in future. All right. So that's it from me for this video, and I wish you all the best for the next quest. All right, take care. Bye-bye.